As we continue in linear equations, we look at section 2.2. This is going to be graphing using tables of values. Some of you don't like to use the table. However, I'm going to impress upon you the importance of using a table, showing your work and getting your points, and then being able to plot those. So this first part, we're going to go through some steps. We're going to say graphing an equation from a table of values. First thing I want you to do is I want you to substitute in an x value into the equation. And then you're going to solve the equation for the y value. Then you're going to fill in the y value into the table. So then fill in y value to the table. And number 4, I want you to repeat for the next x value. So we're just going to keep repeating those same processes. I want you to plot at least 3 points. And the reason I want 3 points is because if you only do 2, you can make a straight line between any 2 points. But 3 points in a row, then you can make your straight line and know that you're on the right track. So at least 3 points. And then use a straight edge to connect the points. Okay, so we have some steps here. So here's our first one. I want you to graph 2x plus 3. So this is the functional part. I want you to put that in here, 2x plus 3, because we're solving for y. Now, the x values, you can pick any number that you want. However, I usually pick 0 as my favorite number, so I put that usually in the center. And I usually go below or above it. So you get to pick numbers for x. Keep it simple. The harder you make it, the harder it's going to be. So keep it simple, like 0, 1, 2, negative 2, negative 1, 0, or negative 1, 0, 1, that kind of thing. So I'm going to do 0. I usually do negative 1, 0, and 1. If I wanted to spread it out a little bit more, because my graph's tiny, I would use like a negative 2, 0, and 2. I'm going to show you all 5 of mine, just because then you can kind of choose what numbers you would rather choose. When I plug it in, I want you to actually go ahead and say like 2 times the negative 2 plus 3. Then it would be 2 times the negative 1 plus 3. 2 times 0 plus 3. 2 times 1 plus 3. And 2 times 2 plus 3. And then simplify it out. So 2 times negative 2 is negative 4. So negative 4 plus 3 would be negative 1. This ordered pair then, out here, this ordered pair x comma y, is negative 2, negative 1. The next one, 2 times negative 1 is negative 2. Negative 2 plus 3 is going to give me 1. So this ordered pair is going to be negative 1, 3. If I plug in 0, 2 times 0 is 0. It's my favorite here. 0 plus 3 is going to be 3. So I know it's going to be 0, 3. It's also my y-intercept. Plug in a 1. 2 times 1 is 2. 2 plus 3 is 5. So 1, 5. And 2 times 2 is 4. 4 plus 3 is 7. So 2, 7. If you take them all and you notice, my slope is 2, because we've talked about this before. And if you go up in increments of 1 here, for every 1 I go up, I'm going to go up 2. So this is up 2. 1 to 3 is up 2. Plus 2 is 5. Plus 2 is 7. So now my dots, plot your dots, and then draw your line with a straight edge. So negative 2, negative 1. Negative 1, 3. 0. Oops, I made a mistake here. Can't be 0, 3. It's going to be negative 1, 1. Negative 1, 1. 0, 3, 1, 2, 3. 1, 5. And 2, 7. And make a pretty line. Now the next question is negative 2, negative 1 a solution? Well, that's one reason why I chose my negative 2 here. Here's negative 2, and with negative 2 I got negative 1, so yes. How does this point relate to the graph? It is in a straight line with other points. So on the line. So if it's a solution, it means it's on the line. All right, so this next one, I want you to try, first of all, you're going to graph it. The thing I want to keep in mind here is same idea, but I want to use the denominator. So my denominator here is 2. So I really want to pay attention to the slope and use numbers that are going to be friendly. So getting whole numbers for me. So I would suggest, again, your 0, but I would probably go with negative 2 and 2. And then I'm leaving extra room there so we can have some working room. Plug in your function, so 1/2 x plus 3, and then in each one of these go 1/2 times your negative 2 plus 3, 1/2 times 0 plus 3, and 1/2 times 2 plus 3. As we simplify that out, half times half of 2 is 1, but positive negative is negative, so negative 1 plus 3 gives me 2. So my ordered pair here is negative 2, 2. Add 0, that's going to be 0 plus 3, which is 3. So 0, 3. And the last 1/2 of 2 is 1. 1 plus 3 is 4. So 2, 4. And plot the dots. So negative 2, 2. 0 is 3. 4 is, or 2 is 4. So there's 3, 4. Now it asks me if 6, 8 is on my line. Well, my slope here is 1/2. So if you know your slope, we can go down 1, back 2, down 1, back 2, down 1, back 2. There's negative 6. Positive 6 would be the other direction. So it would be like 2. So it would be up 1 over 2, up 1 over 2. So at 6, I'm actually at 6. So no. 6 would be 6. Does this point relate to the graph? It is not on the line. Okay, so 6, 8 is not on the line. It's actually above the line. Then graph the next one. So this one's going to be similar to your half. But my points, I'm going to suggest you use the denominator again. So I'm going to put 0 here, and I'm going to go negative 5, and I'm going to go 5. Keeps it simple. So use the denominator, and then the negative of it and the positive of it with 0 in the middle. Try on your own. Please finish that one on your own. The next one, concept 3. Concept 3 says graph the equation y equals 4. So hopefully we remember that y equals 4 means it's going to crosses y-axis at 4. So here's the y-axis. I'm going to cross it at 4, and it's going to go this direction. So basically, my y value is always 4. So y is always 4. So 4, 4, 4, 4, 4. And that doesn't matter what you put in for x. It doesn't matter what you sub in for x. It could be negative 2, negative 1, 0, 1, 2. It's all going to be 4 on the y-axis. Or 4, excuse me, on the y value. graph the equation. So all of these are going to be like -2, 4, -1, 4, 0, 4, 1, 4, and 2, 4. The next one is the x, and it's very similar, except for instead of a horizontal line, this is going to be a vertical line. So crosses the x-axis at -3. X value is always -3. So -3, -3. So my order pair, it's -3 something, -3 something, -3 something, -3 something, -3 something. The y value does not matter, so you could put in 2, -2, -1, 0, 1, 2. Those are my kind of go-to numbers. And it does not matter because I'm crossing the x-axis at -3. 1, 2, 3. And every time. So at -3, -2, -3, -1, -3, 1, -3, 2, etc. All right, then we get to the concept 4, talking about our domain and the range of the function, kind of a refresher from that first day. Domain are your x values and range are your y values. So x values, and then this is the y values. Remember, once each and from least to greatest. So now I want you to graph the equation y equals 3x, y plus 3x equals -2 for x greater than or equal to 0. So in this case, it's restricting me. Restricts my input options. Okay, it restricts my input. So my input here, I have to be greater than or equal to 0. So I could use my fancy 0, but then I have to go above it. So I can use anything above that. I could use fractions if you want, but ideally you'd use like 0, 1, 2, etc. And as I plug it in, I can do a couple different things. I can either rearrange this to solve it for y, and it makes it easier to plug in, or I can plug it in as is. If you try to plug it in as is, you're going to say y plus 3 times 0 equals -2. Well, this is nice because 3 times 0 is 0, so y equals -2. So I can plug in -2. But the other numbers, plugging in a 1, I'm going to have to do y plus 3 times 1 equals -2. So y plus 3 equals -2 minus 3 minus 3, y equals -5. The other option to that would be to rearrange this, which is what I like to do. And I would say that take away 3x, take away 3x before I start plugging in things. And I would say y equals -3x minus 2. I would then plug it in here and say it's the -3x minus 2. So -3 times the 0 minus 2 gave me -2. -3 times 1 would give me -3, minus 2 gave me -5. -3 times 2 is -6. -6 minus 2 is going to give me -8. So you can do it either way. Plug it in and solve. Either way, you have to solve for y. So in this case, I'm going to end up with 0, -2, 1, -5, and 2, -8. So at 2, I'm at -8. And make a pretty line. Now I'm going to ask you what the range is. Okay, so your range are your y values. So if the range are the y values, it's okay. So if I look at here, I'm going -2. X value cannot be greater than 0. So I actually have restrictions here. It can't be greater than 0. It has to be greater than 0. So I need to erase this because my x values can't go back here. So they can only be from here and then going this way. So my range, like top to bottom, is going to go there and below. So the y values, so y is going to be less than or equal to, and my biggest number that it is at negative 2. So y is smaller than or equal to negative 2. Okay, number 7, or example 7. That gives it to me with a domain, and I'm giving you restrictions again. Negative 2 is my smallest, and 5 is my largest. So I'm going to go negative 2. I'm going to put my 0 in the middle, and I'm going to do 5 on the other end. Because you have to have 3 points. I, again, would rearrange this. So I'm going to say add 2x, add 2x. So I get y is equal to 2x plus 3. I'm going to plug that in here. So 2x plus 3. And then now I can plug it in. So 2 times negative 2 plus 3 gives me negative 4. Negative 4 plus 3 is negative 1. 0, so 2 times 0 is 0, plus 3 is 3. And 2 times 5 is 10, plus 3 is 13. So since I have the bottom and the top of my x for my domain, we'll have to look at our range here in just a minute. So my points that I ended up getting are negative 2, negative 1, 0, 3, and 5, 13. Oh, there's 10, 11, 12, 13. So up here. Now, it doesn't go beyond those, so I'm going to just make a line directly to them, no arrows on the end, because that's my end. My highest point is 13, and my lowest point is at negative 1. So my range is going to be negative 1 to 13, and the y value is in between. So just like we did on that number line last chapter, we're kind of doing the same thing here, but we're using the x and y values for the range and domain. So remember that, no arrows. All right, the next one. Concept 5. The number of pages a student types given in the equation, 4p. So if that's 4p, or 4t, excuse me, oops, 4t. Where t is the time an hour spent typing. The student plans to type for at most, likes to jump today, at most 2.5 hours. So here's my equation. At most 2.5, so 2.5 or less. So my x values, this is time. And number of pages. So this is going to be number of pages, P. Graph the function, identify the domain and range. So the domain are the number of pages, right? Or excuse me, the time. And the range is your number of pages. Because this is your x and this is your y, or your t and your p. And I know my function is 4t. At most 2.5 hours, so it's going to be my biggest number here is going to be 2.5 largest. 0 is going to be my smallest because you can't go below 0. And then I'm going to pick like maybe 1 and just plug it in. 4 times 0 is 0, so that goes right here. 4 times 1 is 4. So 1 and a half, 4. And then 4 times 2.5. And 4 times 2.5 gives me 10. So at 2.5, I'm going to be at 10. And it's at most, so we're going to go like this. And you can't go below 0, so my range, like my domain, is going to be x is greater than or equal to, actually less than or equal to, because it's at most, less than or equal to 2.5. And 0 is my low end. And then the range, the highest I ever get is 10, the lowest is 0. So 0, y, and 10, and put in those less than signs. That's it.